नमस्कार मित्रों, उम्मीद है आप सब अच्छे होंगे और इस लॉकडाउन पीरियड में इस नए मोड ऑफ टीचिंग का पूरा लाभ उठा रहे होंगे। अब तक पिछले कई वीडियो हमने रिफ्रैक्शंस के बारे में देखे और उनके बारे में काफ़ी कुछ मैंने बताने की कोशिश की। In the coming videos or video lectures, I will tell you about the refraction through the lenses, spherical lenses, and we will come to know about the image formation by spherical lenses. What are the important rays to be considered for drawing the image formation cases in lenses. So in this video of this sequence, the first lecture I am delivering about the refraction through the spherical lenses. So let us begin with this new lesson. So let us begin with this new lecture. In this we will understand about the refraction through spherical lenses. It is well known that spherical lenses are of two types: convex lens and concave lens. When the parallel beam of rays incident on the convex lens, these rays are found to converge at a single point. And that point is known as focus. It's a real point. There we can see the rays to converge and passing through the single point. So this lens is converging lens. On the other hand, when it comes to concave lens, then the parallel beam of rays of light appears to diverge from a single point. So this lens is diverging lens. And it is known as concave lens also. So you can see these rays are not really passing through this single point. When we produce them backward, then only they seems or appear to diverge from this point F. So focus of this concave lens is not a real point, it's an imaginary point. but the focus of convex lens is a real point that can be obtained on the screen as well. One more thing you will understand here, that there is a point optical center in both convex and concave lenses. So the ray which is passing through the optical center goes straight. It does not deviate from its original path. The distance between optical center and focus is known as focal length, denoted by small f. So this is the behavior of the convex and concave lens for the parallel beam of light. Then we have one more important term related to these two lenses, and that is principal axis. The line joining optical center and focus is known as principal axis. So all these rays we have taken are parallel to the principal axis, and after passing through these two lenses, or I should say after getting refracted through these two lenses, they are converged and diverged respectively from the convex and concave lens. Now we have to understand few more important aspect of the refraction through the lenses, and these are very important as far as the image formation cases of the lenses are concerned. The first thing is that we can say rule 1 is the ray parallel to principal axis passes through focus for convex lens, or appear to pass through focus for concave lens. So that we can see separately by drawing the diagram. Once again, I am taking the convex lens. This is the principal axis of the convex lens. This is one of the parallel ray to the principal axis. So after getting refracted, it passes through the focus. On the other hand, when we talk about the concave lens, this ray diverged, and when we produce backward, it appears to pass through the focus. The second rule is reversibility. Reversibility means and this is very important to learn and remember whenever we draw the diagrams of the image formation by the spherical lenses. If you reverse the path of the ray, it means if the ray is passing through the focus in case of convex lens and appear to pass through the focus in case of convex concave lens, then these rays will become parallel to principal axis. Let us see how we will draw this in diagram. First I am taking convex lens. This is principal axis. This is focus. Let the rays passing through the focus. Then it will become parallel to the principal axis. While in case of concave lens, be very careful, because a very simple mistake is committed by students most of the time. That's why I have used only single word, reversibility. So just see, the ray was not passing through the focus. Really, when we produce the refracted ray, it was appearing to diverge from the focus. So in case of concave lens, when you draw this ray, the ray will not really pass through the focus, it will appear to pass through the focus. So this is the ray, incident ray, passing or appearing to pass through the focus. After being refracted, this ray will become parallel to principal axis. Sometimes if you consider this ray in wrong manner, that will result in the wrong ray diagram. Let us understand this, how this sweet mistake is committed by children. If you take this ray and you just draw this ray, so this is not correct, this is wrong, this is right. So the reversibility, I think, is very clear to you, and rather it's very important when we draw the ray diagrams by the spherical lenses image formation. The third one is very simple. If the ray passes through the optical center, it goes straight. So I just take this ray in this way. This is going straight without any deviation. Similarly, if we take into consideration the concave lens, then you will see such ray also goes straight without being refracted. So in this small lecture, I explained you how the rays are refracted by the lenses and what are the important terms or rays which are to be used when we draw the ray diagram for image formation by lenses. This is enough for this concept. In the next lecture, we will talk exclusively about the image formation by the two lenses and what are the characteristics of the images so formed. Thanks for watching the video. Keep watching.